Okay, question 4. The speed of a car traveling along a straight road decreases uniformly from 12 meter per second to 8 meter per second over 88 meter. Calculate the acceleration of the car, the time of the car traveling over 88 meter, the time taken for the car to stop, as well as the total distance traveled until it rests. Okay, so firstly, I'm gonna extract the information from the question. So what do we have? We have an initial velocity of 12 meter per second, and then it decreases uniformly to 8 meter per second, and then we have the distance traveled, which is 88 meter. Okay, so now we have to find the acceleration of the car, or actually it is the deceleration of the car. Why did I say deceleration? Is because it mentioned in the question it is decreasing uniformly. Okay, so we can use what formula? If you can't remember, you can just write down the formula at the side. We have VU plus AT as UT plus half AT square, and then we have V square U square plus 2AS. Okay, so now we have to find the acceleration of the car. All of it has acceleration. However, we only have specific amount of information in which these two formulas has to have the time in which we don't have. So we are going to use this formula. Okay, so V square U square plus 2AS. Alright, so we are finding the acceleration. So A is equal to V square minus U square over 2S. Okay, so 8 square minus 12 square over 288. Then you'll get the acceleration to be negative 0.455 meter per second square. So remember, negative indicates deceleration. Okay, so it indicates deceleration. Next, we have to find the time of the car travels over 88 meter. Now we are looking for time. So what we can do is we can then use V U plus AT. So we have to find the time, V minus U over A. Okay, so V is 8 minus 12, negative 0.455. Then you'll get the time to be 8.79 seconds. Okay, you can also use this formula, but I feel like it's easier to use this one. Okay, this formula, sorry. Okay, now question C. So question C, the time taken for the car to stop. Okay, so for the car to stop means dia punya final velocity should be 0 meter per second lah. Okay, right? So, and then we have the U, which is 12, and then we also have the acceleration to be negative 0.455 meter per second. Then we can use the formula U plus AT to find the time taken for the car to stops. Okay, so V minus U over A. So V is 0 minus 12 over dengan negative 0.455. You'll then get the time to be 26.4 seconds. Okay, so that is the time for the car to stop. Final question, the total distance traveled by the car until it rests. Okay, so this one, since it asks us to find the distance traveled until it rests, means it is up till V equal to 0 lah. So what we can do is we can use this formula, T square. 88 meter is not the answer, okay, because 88 meter is actually for when it decreases uniformly from 12 meter to 8 meter per second. It hasn't yet stopped, so that's why we have to find the distance when it stops. So when it stops means the time that we will be using is the time we've calculated in C. Okay, boleh ya? So substitute the values. U is 12, 26.4 plus half, acceleration is negative 0.455. 26.4 square. You'll then get 158 meter to be the distance traveled by the car until it rests. Okay, so that is question 4.